In the previous session, we have discussed about what is biotransformation. What is biotransformation? It is a chemical alteration of drug inside the body with the primary objective is to convert the drug from lipid soluble to water soluble. Now there are two types of biotransformation reaction, that is phase 1 reaction and phase 2 reaction. Now you have to understand the basic difference between these two. Now in phase 1 biotransformation reaction, a functional group like the OH or COOH or NH2, this group, they have been either added or removed. And again, the one thing that is clear for both phase 1 and phase 2 biotransformation reaction is to make the drug more water soluble, and hence in the phase 1 reaction all these polar groups, they have been added. Okay, fine. Now what is the net result of the phase 1 biotransformation reaction? The drugs, they may become active or inactive. So at the end of the phase 1 reaction, the metabolites, they remain either active or inactive, and those which remains active, they enter into the phase 2 reactions. And as I have told in my previous session that at the end of phase 2 reaction, in majority of the cases, the drug becomes inactive. Okay, there are few exceptions, but when I am going to tell you, unfortunately, you will remember that exceptions and you will forget the basic endpoints. That's why I am not telling that. Okay. So at the end of phase 1 reaction, either the metabolite remains active or inactive. If it remains active, enter into the phase 2 reaction and ultimately it becomes inactive. Now phase 1 reaction, it is also called, we are first focusing on the phase 1 reaction. It is also called non-synthetic reaction because no synthesis occurs. Then the question must arise in your mind that then which is a synthetic reaction? Obviously, that is a phase 2 reaction, but synthesis, now synthesis of what? Now synthesis occur in form of the drug or its metabolite, they combine with the endogenous substrate and make, here the basic difference is the formation is having a larger molecular size, and water soluble is there. So now there is no question of reabsorption or remain in the body. Now again come back to our phase 1 reaction. Okay, so this question may be asked in your exam, that as all these are synonyms, okay, describe the phase 1 biotransformation reaction in detail. As there is a addition or removal of the functional group, it is also known as a functionalization reaction. Now, which are these reactions? That is one. These I have already told you in the previous session, and these are oxidation, reduction, hydrolysis, cyclization and decyclization. Okay. Now the second thing is where this reaction occurs. That is one, and at least you should remember one or two examples of the drugs which are metabolized by these processes. Okay. So now, as the name suggests, in oxidation, there is addition of oxygen, or I just explain you over here. Sorry. In oxidation, there is an addition of oxygen or any other negatively charged compound. Say for example, in the form of hydroxyl or in the form of carboxylic acid or amide. Okay. And you should remember that this is the most common phase 1 biotransformation reaction. Okay. And it involves, obviously there is the involvement of the enzyme, there are a group of monooxygenases they are involved, and ultimately there is a involvement of which enzyme? These are CYP450 enzymes. You should also know this. You must learn in the first MBBS. These are the cytochrome P450 enzyme, and these are present in the smooth endoplasmic reticulum in liver. Okay. And these enzymes, I will prepare a separate video on this CYP450 enzymes and its pharmacological importance. Now one thing it should be clear, that this question must arises in your mind, that there are significant inter-individual variation between the metabolism of a single drug. Okay. And the similarly will reflected in the plasma concentration, even in the onset of the action, even in the duration of the action. The reason is that these cytochrome P450 enzymes, they start developing at the prenatal age, and then this development continues till the adult age and even further, and there is a significant variation in the number as well as the activity of this CYP450 enzyme, and that's why there is a differences in the metabolism of the drugs. Now there is another point, that these CYP450 enzymes, these are of two types. These are constitutive. So this is not going to create the problem, but they are inducible also. Inducible means the number of this CYP450 enzyme, it can be increased. Now, which are these inducers? This can be either drugs or environmental agents or carcinogens smoking, all these will lead to microsomal enzyme induction. Okay. Now the clinical importance of these microsomal enzyme induction and inhibition, I will again prepare a separate video on that. So we again come back to our original point that the first reaction is the oxidation. So there is an addition of oxygen or negatively charged group either in the form of this or you just think the reverse of this. There is a removal of hydrogen or positively charged group. Now, as I have told you, you have to remember at least one or two examples, but again, it is not like that the example that I am telling that is important. Each and every example carries the similar weightage. Both the CNS depressant drugs, you can remember like this, barbiturates and benzodiazepines. Barbiturates and benzodiazepines, they are metabolized by this reaction. Okay. Now after the oxidation, next is the reduction. You have to just remember that exactly opposite action to the oxidation occurs in the reduction. Okay. And the examples are chloramphenicol, halothane, warfarin. Okay. Then the next is hydrolysis. Hydrolysis. Hydrolysis means there is a cleavage of the ester by adding the water with the help of the esterase enzyme. If there is amide, then there is amidasis. Okay. And the most common example you can remember is if you just go through the cholinergic system, and again in this the cholinergic agonist, there are different cholinesters, and they are degraded by acetylcholinesterases. Okay. Now these three are the principal reactions. Okay. Oxidation, reduction and hydrolysis. Again in this, oxidation is the most common. Okay. And as I told you, you should remember the examples. In the oxidation, barbiturates and benzodiazepines, reduction, chloramphenicol, warfarin, halothane, hydrolysis, cholinesters, and there are two reactions which are not clinically significant, and these are if there is a formation of the ring structure, formation of the ring structure, and so there is a formation of the cycle. That's why it is called the cyclization. That is seen with an anti-malarial agent proguanil. And if the compound is already in the cyclic structure, and if you open it, that is called the decyclization, that is seen with the phenytoin. So this is all about the phase 1 biotransformation reaction. In the next video, we will discuss about phase 2 biotransformation reaction.